So if a rod is connected to, say, a wall by a hinge or a pivot, so like this, so here's our wall, and we have the rod like this, and there are forces that are acting on this rod that aren't parallel. So let's say this is being pulled by some sort of rope this way, so we have a force that goes that way. You can see this force isn't acting parallel to our rod, and it's providing some component that is effectively going this way, attempting to pull the rod out of the wall, but also applying some component upwards, pulling the rod up if it was hinging at our point here. Okay, the issue comes then is the reaction force at our hinge point isn't just perpendicular to the wall. It's parallel and perpendicular. So we would have to consider the reaction force as two components. So reaction forces can have parallel and perpendicular components. Okay? So even though we normally say the reaction force is perpendicular to the surface, in this case where there's forces that are acting not parallel to the rod at the pivot, there can be also parallel components of the reaction force. Okay, so if a rod is attached to a wall but is held against the wall by friction, so say for example we have a wall here and we have a ladder leaning up against it. If the only thing stopping this ladder falling down is friction, the friction replaces the vertical component of the reaction force. And then we only really need to consider the perpendicular one that's going this way, the force that is stopping the ladder going through the wall. Okay? So sometimes a rod is positioned between two surfaces. So again, a ladder is a good example. So here's our floor, here's the wall. So we could have a ladder that is going like this. Now, there could be friction on one or two of the surfaces. So you could be experiencing friction against the wall. You could be experiencing friction on the floor. You could be experiencing friction on none of them or both of them. So the questions will always give the different coefficients of friction. So the wall and the floor will probably have different coefficients of friction because, of course, they're made of different things. Brick might be slightly more rough than, say, tarmac, and so on. So the question should provide the coefficient of friction. This style of question is a very common exam question. So questions can also be asked about bodies leaning against surfaces that are neither horizontal nor vertical. What I mean by this is we could imagine here's our floor, and then someone's got a really bad builder in, and they've built a wall that is nowhere near vertical. If I want to put a ladder here now, you can see here, yeah, the floor is still horizontal. That makes it nice and easy to think about the forces. Here, if we want to talk about the reaction force, it becomes a little bit harder, you might think, but we can still consider just perpendicular to this plane and parallel to this plane. The only thing is you might have to do a little bit of trigonometry depending on how the ladder is applying force to the wall. So another example that they like to ask is if a rod has support that is resting on in the middle of its length. So for example, here's the floor, there's our wall, there's your ladder or some sort of frame, and there's some sort of support in the middle here. Okay, so again, if we're thinking about reaction forces, we will just imagine the force is perpendicular to our beam or our ladder here, resting on top of the support. So finally, some questions might ask you to find a range for the coefficient of friction that we call mu. Okay, so the coefficient of friction isn't always constant, so it could vary on things like speed, where other supports are acting on our beam, so of course then the normal reaction would decrease. So in this situation here, the normal reaction at this point would probably slightly decrease if we put this beam in, because this is supporting some of the vertical component. Okay, which then means because friction is F equals mu r, well, the normal reaction's decreased, but the force we want to stay the same, so mu would have to decrease. Okay? So when we come to work out the coefficient of friction, rather than working with this, we have to work with F is less than or equal to mu r if we want to work out the range, okay? Because it's always less than or equal to this, it can't be greater than.